basically speaking, the driver of all environmental compliance of the diesel system is the high-pressure common rail at this point. In 2007, the EPA passed the 2007 on-highway diesel rule, and in that, when that was passed, there was a 90 and 92% reductions in NOx and particulate emission mandated at that time. And when they were doing their original work to understand, well, how is this going to impact the exhaust systems of the diesel engine, it was considered necessary to have an exhaust after-treatment system that was sensitive to sulfur. In the end, the engineers at the OEMs, many of them were able to engineer systems that were very close without that catalyst system. But at the time the legislation was being put in place, a sulfur-sensitive system was there. And so when that mandate was created for NOx and for particulate, the first arrow that kind of propagates down into other systems was the fuel. The fuel had to drop sulfur. And so there was a 97% drop in fuel sulfur from 500 parts per million down to 10. And that's fine, it's a cleaner fuel, but in order to get your fuel that clean, diesel fuel was subjected to hydrotreating. And hydrotreating is a process in the refinery that was designed to remove what you call heteroatoms, your sulfurs, your nitrogens, anything that's going to dissolve a pipe when you're in the middle of refining. So in addition, however, to removing the sulfur, hydrotreatment also removed the native chemicals within the diesel fuel that gave it a natural lubricity. Particularly in North America, where we have, coast-to-coast overland hauling, enormous distances that trucks have to travel, there was an interest in keeping the price of diesel fuel low. So the specification for diesel fuel historically was always kind of loose, so that the refiner could put pretty much anything into that blend as long as it complied with this loose standard. So with the introduction of ultra-low sulfur diesel that complied with the 2007 mandate, came this extremely clean fuel, the cleanest fuel, in fact, that's now coming out of the refinery, cleaner than aviation, cleaner than jet fuel. In the past, it was the last one, it was the dirty one that kind of did the cleanup. So cleaned up the fuel with hydrotreating, you removed all the sulfur, but you robbed it of its native lubricity. So you say, well, how do you find that out? Well, the reason this came into light was when ultra-low sulfur diesel was placed in high-pressure common rail diesel engines, there was tremendous amounts of high-pressure fuel pump failures due to excessive wear. And in response to that, the additives business responded with tried and true lubricity additives that improved the lubricating capability of the fuel. And these are molecules that have been around for a very long time, proven in diesel engines and engines of all kinds. So it was a good thing to do. But a lubricity additive, a rust inhibitor, all of those additives are unique in the sense that they've been designed to run to have two parts. You have a part that likes water and you have a part that likes the fuel. And the reason they promote lubricity is the part that likes water will tend to migrate to a metal surface, because a metal surface is very much like water. So this part of the molecule will migrate to the metal surface, and then the part that likes oil will kind of dangle out into the fuel. And it creates a lubricating effect or a wear protection effect, because as metal surfaces shear against one another, they're no longer contacting each other, but you have this molecular level sheen of oil at the surface that's been put there by the lubricity additive. Well, the problem is lubricity additives, they're not intelligent beings. They like things that look like water. And water in fuel is also a surface that it will migrate to and absorb onto. So with the introduction of lubricity additives, the impact on wear was mitigated, but the unseen problem, the next arrow in the cascade into filtration, was by absorbing onto the surface of water, the lubricity additives, which belong to a chemical class known as surfactants, the surfactants caused water to exist in much smaller droplets and stabilized those droplets in the fuel. So every fuel filtration media that is designed to remove water from diesel fuel was disarmed by this new fuel. So in the past, media was designed to look very much like fuel, so that when water came to meet the media, it was rejected at the surface and collected in a bowl. But now the water looks like fuel. It has a surfactant absorbed on the surface, and it passes without restriction through some of those types of media. And so with the introduction of surfactants to meet a requirement for ultra-low sulfur diesel, in the end, it snakes back around and puts the high-pressure common rail once again in jeopardy, because water is a corrosive element that can corrode the surfaces of the high-pressure common rail.